Hello and welcome to section 8.2. We're going to now move from polygons to quadrilaterals. We're going to study all four-sided shapes basically. Got parallelograms, squares, rectangles, rhombuses, trapezoids. That is the we're going to be covering the next couple days. Here are the answers for 8.1. If you guys have any questions on that, let me know. Okay, so a parallelogram, by definition, this is the definition, and it's important to know this is the definition, is a quadrilateral, so four-sided polygon with both pairs of opposite sides being parallel. The term parallelogram can be written using this little symbol right there, and you have QR parallel to PS, and QP parallel to R. So if you know it's a parallelogram, the only thing that you actually know by definition is that the opposite sides are parallel. The theorems that we're going to talk about are the properties of the parallelogram. So it's important to know the differences between those. So the first property is that the opposite sides are congruent, and the second property is that the opposite angles are congruent. We're actually going to prove these. I'll prove one of them here in the video. Do a quick sample problem for you guys. A lot of the math behind this stuff is really easy. So for example, like here we have a parallelogram, and you know it's a parallelogram because the opposite sides are parallel. So that tells me then that the opposite angles are congruent, and the opposite sides are congruent. So the math really isn't too difficult when you're, the algebra behind this stuff. And in this problem here, we're gonna go back to our two-column proof here. So we're gonna prove that the opposite sides are congruent. I'm gonna show just one case of this. The other case, you just draw in the other diagonal. So like you just draw in PR, and then the whole proof is the same thing. So I'm just gonna do one case of it. We'll just go with showing. Actually, let's see once. Might be able to get both of it out of this actually. Two triangles are congruent, then the two sides, yeah, CP, yeah, we can actually get both of it just out of this. Some of the proofs you have to do the other diagonal to get it, like the angle one. When you're showing the opposite angles are congruent, you actually have to do it twice. So we're going to start with, let's see, given that PQRS is a parallelogram given. So by default, we're going to say that PQ is parallel to RS. That is definition of a parallelogram. So you have to actually state that there. Now, I'm not going to say the other lines are parallel because what I'm going to do here is I'm going to use this transversal. And I'm going to call this angle 1 and this angle 2. Because those two lines are parallel, angle 1 is congruent to angle 2 by alternate interior angles. Okay, now then what I'm going to do is I'm going to say that PS is parallel to QR. Okay, and again, it's the same thing here. Actually, I should leave that 1 and 2 in there. Definition of parallelogram. And then now here, because these lines are parallel, it makes these angles 3 and 4 congruent. So angle 3 is congruent to angle 4. Again, alternate interior angles. And then I have a reflexive side. QS is congruent to SQ. Reflexive. And then the triangles are now congruent. So this is congruent there, and I should mark my angles. 1 and 2, 3 and 4. Okay, so angle side angle. And then since the two triangles are congruent, the sides are congruent. So PQRS, PQ, congruent to RS, and QR and PS. So a lot of review here. Okay, here we have transversal setup here. We have same side interior. If these lines are parallel, what do we know about x and y? Well, x and y have to be supplementary. X plus y equals 180. All right, so the idea here is we're going to make a parallelogram, make these parallel too, and same side interior angles are supplementary. So that suggests this theorem right here. If we have a parallelogram, then the consecutive angles are supplementary. So that could be these two, or these two, or these two, or these two. All those are going to be supplementary. And this proof is in the homework. It's a fun proof. I like that one a lot. And this is the one that most students aren't going to naturally think of here with quadrilaterals. The diagonals bisect each other. So the diagonals cut each other in half. So this segment QM is equal to SM, and then PM is equal to MR. Those are going to be equal there. And then there's just a question to go here. The diagonals here intersect at point P. What are the coordinates of P? Well, in order for them to bisect each other, P has to be a midpoint of any of either LN or MO. So O is 0, 0, and M is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. M is 7, 4. So I could just find the midpoint of those 2 points there, and then that'll give me P. So 0 plus 7 divided by 2, comma, 4 plus 0 divided by 2. So we're looking at 3.5, comma, 2. That would be that point P right there, because it's got to be in the middle. So I just use the midpoint formula there. And then here's a few questions that we can try, just to find some various measurements here to apply the new properties. So the first one they want is NM. Okay, well, it's a parallelogram. I know that because it says it. So if KN is 2, NM is also 2. Then they want KM. Well, KM would just be 2 plus 2, which is 4. JML. So JML, that would be that angle there. If this is 110, this angle has to be 70 because they have to be supplementary. And then KML. So KML, find this angle KLM quite easily because I didn't see this 30 here. So that has to be 40. Oops, sorry about that. Okay, that's all I got for you guys. There's going to be some proofs in your homework tonight. Make sure you give those a try. Basically, a lot of it involves what we've learned before. So if you guys have any questions, let me know, and I'll see you in class. Thank you.